Problem 76. A soccer player weighed 70.7 kilograms before a match, drank 1.8 liters of liquid, density 1.05 grams per milliliter, during the match, and weighed 69.3 kilograms after the match. How many pounds of sweat did the soccer player lose? So there's a lot of information in this problem. It's asking us for the weight that the soccer player lost. So the soccer player weighed this amount initially. He added some weight by drinking liquid and must have lost some weight through sweat. And then after the match, here is his final weight. So the question is asking us, how much weight did the soccer player lose? So here's the question. I'll underline that. How many pounds of sweat? So we're looking for, that. The question gives us the initial mass right here. So here's the mass. I'll just put the initial mass. We're given the final mass right there. And then we're also given the amount of liquid that he drank, he or she, I guess, drank, and that's mass that's added as well. So here, we're not told the mass of the liquid that's added, but we're given its volume and density. And if you know the volume and density, you can get the mass. Because remember, density equals mass over volume. And so you can solve for the mass. The mass equals the volume times the density. So knowing these two will get you that. And we're given the volume and the density of the liquid, so we can figure out what the mass of the liquid is right from that. Now, what we need is some sort of some way to calculate the pounds or the amount of weight that's lost. So can we relate all of these? Well, we can. So if this is how much the soccer player weighed at the beginning, and then this is the amount of weight that's lost, the liquid is the amount of weight that's gained, the sweat is the amount of weight that's lost, and then here's the final weight. We should be able to combine those all into a single equation. So here is how you would do it. The initial mass, okay, if a certain amount of mass is gained through drinking liquid, and then a certain amount of mass is lost through sweat, I'll just call this MS, for that's the sweat. Okay. So you take the initial mass, you gain a little bit of mass, you lose a little bit of mass, and then that you will end up with your final mass. Okay, this equation makes sense. Here's what you start with. If you add a little bit and then take a little bit of away, then there's what you end up with. Now let's start plugging in everything that we know. We know the initial mass, so I'll just plug that in. That's 70.7 kilograms. We know the final mass, that's 69.3 kilograms. Okay, let's plug in everything that we know. We're looking for the mass of the sweat. Okay, we're looking for the mass of the sweat. So it wants to know how many pounds of sweat. Okay, the weight of the sweat, or the mass of the sweat. So the last thing to plug in is the mass of the liquid, and so we're going to get that through this relation right here. The mass of the liquid equals its volume times density. Let's bring that down here and figure that out before plugging it in. So the mass equals the volume times the density, and the volume is 1.8 liters. 1.8 liters. And the density is 1.05 grams per milliliter. Grams per milliliter. So 1.05 grams per milliliter. Now, to take volume times density, the units need to be the right kind of unit. So liters does not go with milliliters. We have to convert the volume to milliliters first before multiplying it by the density. And so we can do that. To convert liters to milliliters, we know that 1,000 milliliters is the same thing as 1 liter. Okay, so here, this is the volume, right? That's the volume, and then multiplied by the density, 1.05. Now, you can see the units canceling. Liters cancels liters. Now you have the milliliters canceling the milliliters, and then the mass would be given in units of grams. Okay. So everybody else is in kilograms inside this equation. If we calculate this, we'll be left with grams. Let's just calculate it, to get grams and then figure out what to do with it. So here is the calculator. So we got 1.8 times 1,000 times 1.05, and I get 1890. So that's 1890 grams. Now, before plugging that in, we need to convert this to kilograms, because you add kilograms to kilograms. You need kilograms here too. So, and that's easy enough to do. To convert grams to kilograms is 1 kilogram is 1,000 grams. And so that's going to be equal to 1.89 kilograms. Okay, and now we can substitute that in right there. So 1.89 kilograms. Okay, so now we finally have this equation right here. So here, let me highlight that. So we have this equation with only one unknown. And we can solve for this mass of sweat. So, the mass of the sweat is going to be equal to, if we move this to the other side, if we move that to the other side, we move this to the other side, you add the mass of the sweat to both sides, and you subtract 69.3 from both sides. Then what you'll be left with here, let me rewrite the equation. So 70.7 kilograms plus 1.89 kilograms, and then minus 69.3 kilograms. All of that is going to be equal to the mass of the sweat. Sorry, I kind of overlapped with what I was writing before. So I've just rewritten this up here. I moved that to that side, I moved this to that side, and this is what you're left with. Oh, that's 69.3. That should be in blue, shouldn't it? So let's put that in blue. 69.3 kilograms. Okay, now we can finally solve for the mass of the sweat. The mass of the sweat equals, let's punch it in, 70.7 plus 1.89 minus 69.3. and I get 3.29. So 3.29 kilograms. Okay, you're almost done. You were asked about the weight of the sweat, but it wants it in pounds. Okay, so here's where you look up the kilogram to pound conversion using that English to metric conversion table. That's table 1.4. Okay, table 1.4 right here. 1 kilogram is 2.20 pounds. Okay, and then let's just write that down. So one kilogram is 2.20 pounds. So we can put that in as a conversion factor, get rid of kilograms, put that on the bottom. 2.20 pounds goes on top, and the kilogram cancels the kilogram. And then this is going to be, let's put it down here. That's going to be equal to, let's see, let me punch this in. 3.29 times 2.20, 7.238. 7.238 pounds. And let's see. Sig fig issues. The mass of the sweat actually is going to be, when you calculate the mass of the sweat, we should have done this before. Okay, using the addition and subtraction rule. Okay, this one goes out to the 10th, that goes out to the 100th, that goes out to the 10th. So, using addition and subtraction, we're going to be limited to the 10th. So this is actually a 2 sig fig number right here. So when you convert this to pounds, you got 2 sig figs, okay, times that, which is 3 sig figs. So you're going to be left with 2 sig figs. This is going to round to 7.2. 7.2 pounds. And there you go.